Yeah, thank you for giving a good introduction. Yeah, I'm Jobin, and I'm working from India. And this presentation I originally proposed and prepared by Sergey, and we worked together. We were senior support engineers for Percona, supporting Postgres. Yeah, so since the lack of time, I'm directly jumping into the topic. So today's agenda is why we need a connection pooler at all. So what are the challenges we are facing if we don't have a connection pooler, and how these connection poolers are addressing that problems. And then we are going to look at some external connection poolers and their features and advantages. And finally, we are going to discuss some of the limitations of these external poolers. I think in the previous talk, we already mentioned about the importance of connection poolers. So this is a closer look. Okay, why we need a connection pooler. Okay, so the Postgres is a process-oriented database. So every client connection needs a dedicated server process. Okay, so when a user connects, there is a corresponding server session getting created. So the process working has a lot of overhead. It has memory allocation, and within the Postgres itself, it has to do the housekeeping, the cancel keys, and because the main server process need to track all the child process it creates and signal them properly. And then the child process need to complete the authentication, communicating with the client, the user credentials and things like that. So that there is a lot of overhead. And at the OS level, we have further overhead. But in new versions of Linux, this OS level overheads are really optimized by this copy on write and overcommits and things like that. A lot of optimization done on the OS level. Still, there is a lot of overhead. Yeah, and generally, more than a thread-based system, the process-based systems has more overhead in establishing a connection. And we see some of the things in the database. When a not so optimized server is used, we'll keep seeing a lot of new connections coming in and going when majority of the sessions are sitting idle. And yeah, so we see a lot of idle sessions hanging around in the server, eating up the memory and resources. Yeah. So the takeaway is that the process creation and removal has a lot of overhead in Postgres as well as in the OS. It consumes a lot of server resources. Okay, and the cost of idling connections. So there is, as I mentioned, there is a memory overhead and scheduling overhead and locking overhead. So if the logs are per process, so to check the log conditions, many of the semaphores need to be checked. So as the number of connection increases, all these overheads increases. So I'm not going to the details. So the how the semaphore allocation happens, the numbers are there on the screen. And another problem is if there is a spike in load, we need to accommodate that. So the DBAs tend to keep a higher limit for the connections. So because of that, for example, if the server is can handle 100 connections, DBA may keep it 1,000 connections to accommodate the spike. But those things will result in server abuse. Too many sessions will be coming and unnecessarily slowing down the servers. And we have seen a lot of outages, poor performance, and system unavailability. Okay, so we talked about the overhead. Now we are going to look at the one simple thing in the overhead, the impact of authentication. Okay, in Postgres, we can have a trusted authentication. For example, I can trust the connection coming from a particular IP. So there is the overhead is very less. So if you look at the number, this is taken from a very low-end machine to show the impact. It's not a good server configuration. Yeah. So if the TPS is 130, and if you incorporate a password authentication, the password exchange happens. So the TPS drops to 95. And if the password authentication happens over a TLS, the secured connection, it's further drops to 72. So this is the connection establishment and disconnection overhead. But if the application is maintaining a persistent connection on the same machine where we got the 72 TPS, the TPS jumps to 658. So we can clearly see the impact of the connection and disconnection. Just one part of the problem, the authentication. Okay. Yeah, and to overcome all these things, the solution is use connection poolers, and always we recommended application side connection poolers if it is available and it can be properly configured, because that has a well integration with the ORM components, and but at the same time there is right sizing challenges, because there could be multiple servers connecting to same database, and in the connection poolers could be sitting in multiple places. So yeah, right sizing is a challenge. Yeah. Yeah, and if the application level connection pooler is not sufficient, that's a place where the external connection pooler comes in. Yeah. External connection poolers are applicable if the connection poolers are not tunable. For example, if there is a third-party application where nothing can be modified, nothing can be adjusted in the built-in connection pooler, then yeah, we have to look into the external connection poolers. Okay, and what it really does, the connection pooler initialize a pool of connection at the startup of the application, or at the first connection comes. So if there is a 20 pool we specify, the 20 connections will be made to the database. And generally a user and database combination is defined as one pool. So any connection comes from the same user for the same database, a connection from the pool will be picked up and given. Yeah. The advantage is very less number of connections, very limited number of connections will be serving large number of application connections. And another big advantage is connection request queuing. If there is a spike, all the connections won't hit the database straight away. Instead of that, we can limit, okay, the server can accommodate say 50 connections or 100 connections. Only 100 connections will be allowed, and rest of the connections will be queued in for the execution. So at the application side, there won't be any error like maximum connection exceed or anything like that. The connection will be queued up. So it avoids the contention in the database. So overall, the functioning will be much smoother. Okay. And the external connection poolers can work as a routing mechanism too. If there is a server change, we can just manipulate that at the connection pooler level to route the connection, because it's a system in the middle which can route the connection. Yeah. And coming to the popular external connection poolers, the most famous one is the PG pool. It's more than a connection. It has the connection pooling capability, and like in the previous talk we mentioned, it has the connection routing. It has high availability features, and recently it acquired this quorum and consensus mechanism for HA. And it can avoid single point of failure by adding multiple pools, and it has a built-in watchdog mechanism and VIP failover mechanism, and there are a lot features. I'm not going to the details, but at the same time, with all these features, it is considered as heavy, and in our many of the performance testings, it shows that extra overhead of having all the features. Yeah. So people look for something very lightweight, something can sit in between. As I mentioned, it has high complexity and high overhead. So there comes the PG Bouncer. It is lightweight and performant, and it has features like SSL support and PAM support, using which we can have LDAP authentication. And it's very popular. And it has the monitoring, because since it's popular, it has the community is more vibrant. And it is available from Postgres repositories, from multiple repositories. Most of the Postgres vendors, as Avi mentioned, has that PG Bouncer in their own repositories. So it's widely available. And one of the limitations which PG Bouncer was like, it can occupy only one CPU core. And we are going to see the details in the coming slides. But so recently, from Linux kernel version 3.9 onwards, same pod can be reused by multiple processors. So you can just search for that. And PG Bouncer can utilize those features for scaling better. Yeah, but it's slightly complex. To overcome the limitations of the scalability of PG Bouncer, a new project by Yandex is Odyssey. It's a multi-threaded worker. There are multiple worker threads in the background, and it has same feature, almost same feature as PG Bouncer. In many places, we can call it as a drop-in replacement. But the other side is it's very new, like Sergey used to call it a black horse. Yeah. And there is the build is not widely available, and the ready-to-use builds are using OpenSSL 1.1, and you may face some problems if the OS is not compatible. So it's really new and cutting edge. There are a lot of things to be finished. Yeah. Yeah, and basically it addresses the limitations of PG Bouncer. Okay, so we are going to see some of the performance numbers. As we can see, this is if the connection is persistent from the application side. The blue line shows we have higher performance, because when we incorporate a external connection pooler, it's an extra hop. One more, the connection comes to the connection pooler and goes to the Postgres. So if there is application level persistence, application level connection pooler, that performs much better. Okay, so this is the one thing we need to keep in mind. So it's not advertisement for any external connection poolers. So always application connection poolers works better. And when it comes to PG Bouncer and the Odyssey, because we are just keeping this PG pools because it has a lot more functionality, and the performance is much more problematic, as Avi already mentioned in the last talk. Yeah, so we can see with SSL on. Sorry, without SSL, the connection overhead is less. So the PG Bouncer can reach up to 6,000 levels of in a particular testing environment. But if there is overhead of SSL connection, the PG Bouncer, the performance goes down very fast. So but obviously the Odyssey is slightly slower, but the performance is more consistent. So we tested with 256 connections. As we can see, after some time, if there is a SSL overhead, it matches the same performance as Odyssey. Okay, and what happens? So we saw this is a persistent connection. So that's not the case for external connection pooler. So now let's look at the cases where we need to really use a external connection pooler. The connections are coming and going. If there is no persistent connection from application, the performance is really poor. Okay, it drops, and clearly it is visible that the connection pooler advantages. And if you look at the right side of the slide, we can see that's where this ODC fixes some of the limitations of PG Bouncer because it has multiple processes, cores, threads, which can occupy multiple cores. It can better utilize high computational overhead, say SSL authentication. So ODC is going to give much better performance there. Okay, and so yeah, with the no pooler, so it's obvious. The Postgres with the no SSL always performs better. And with the PG Bouncer, like we already saw this, say PG Bouncer, if there is a lot of authentication overhead happens, the performance drops heavily. But in ODC, the drop is not to that extent. It scales better. It scales better. Okay, so the takeaway is that the application level connection poolers are much better if it can maintain persistent connections, but external connection poolers can be utilized whenever it is really required, and it gives good performance improvement. And we are coming to the limitations. So everything is not green. We need to understand some of the limitations. One is security and auditing, monitoring, and troubleshooting challenges. So when we look at the client address in the server logs, since this is the external connection pooler is a man in middle, all the connections will be coming from this external connection pooler. So we don't have a client address properly recorded. So it affects the auditing and even security part. If somebody gets into if the middle thing get hacked, that's already is a man in middle. Yeah, and the monitoring, we don't know from the connection is coming, and the troubleshooting is again big problem. Okay, so all this the server side traceability of the connections will be heavily affected. So that's one major limitations of external connection poolers. And from the functionality point of view, these are major challenges because the same connections will be reused again and again. So we cannot have a prepared statement. Say a connection comes, and if it prepares a statement, and if it releases the connection back to the pool, and some other connection takes it, or this connection gets another connection from the pool, prepared statements won't work. So prepared statement won't be available, and temporary tables. So that is again a challenge because temporary tables in Postgres are session specific. Yeah. So these are functionality level limitations of external connection poolers. Yeah, and performance and stability challenges. So if there is already a connection pooler which already maintains trying to maintain a persistent connection, many times we keep seeing in client cases where people keep connection pooler over another pooler. So it adds a lot of overhead and without giving any benefit. So the overhead of two poolers without knowing that there is a pooler in the application side. So use it only when required, and just keep assessing whether it is really required. There is overhead in getting the connection from the pool and releasing it back. And there is, as I mentioned, it's a extra hop to the pool and then to the server. And obviously, there could be other overheads, like we discussed. We cannot have a prepared statement. So all the prepared statements or anything which is done at the session level need to be discarded. So there is a deallocate of everything and release the connection back. So the connection poolers itself supports all these options. We just need to specify, but there is an overhead that we need to be aware. And unlike the PG pool, most of these connection poolers may become a single point of failure because all the connections goes through that. If there is multiple applications connecting through same connection pooler, then that could become a single point of failure. Okay, so coming to the references, so we have a good number of references, and we have Percona blog where we discussed about the advantages of this connection pooler. Please refer to that for more details. Okay, thank you very much, and Percona Live, welcome.